Sharp. So, Barry, Thabo plans to buy a car. This is too small. Thabo plans to buy a car that costs 250,000. Okay, fair. He'll pay a deposit of 15% and take out a loan for the balance. So this guy today, Utabo, sees a nice car worth 250,000. Utabo doesn't have 250,000 cash, but he has a deposit. So like a small percentage. Ne? And what is that percentage? He's got 15% of the total value. So which means that, and then after that, and take out a loan for the balance. So he's gonna take out 15% of 250,000, and then the balance for the car he will take out a loan from the bank. So let's just quickly calculate 15% of 250,000. 15% of 250,000. So you guys remember what this means over 100. So I could just make this over 100. So please punch and tell me the answer. Where's my calculator? 37,500. All of us get that, yeah? Fair. So now this means that Utabo um, is going to pay like a deposit of 35,500, and then after that the remaining balance is going to take out a loan from a bank. From a bank. So for how much is the loan? So it's 250,000, the original value of the car, minus the deposit he will have paid. This will give you how much? This will give you how much? Say again. Recalculate it. Recalculate it. Recalculate it. Make sure that this is 250,000, this 37,500. Try it again. 212. Yes, yes, yes. You got it. So in summary, let's summarize everything. This guy by the name of Tavo sees a car, brand new car worth 250,000. He knows he doesn't have the cash. So he's like, but I have a bit of money, man. A deposit never. So he takes out a deposit, and that deposit happens to be 15% of 250,000. We already calculated that. That's 37,500. Okay. So he takes out that deposit. Which means the balance is 212,500. This means that he's gonna go to the bank and take out a loan of how much? 212,500. That's what's going on. Is that clear to everybody? Yes, yes. Sharp. So I'll just quickly reread the statement again. Tower plans to buy a car worth 250,000. He'll pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per annum compounded monthly. Calculate the value of the loan. So the value of the loan is essentially this. How they're asking you how much will you take out the loan for? It's 212,500. So how to calculate it? You could just do this. You could just say 250,000 isn't one calculator minus 50% of itself times 15 over 100. This will give you 212,500. Like it? Or you can do it manually like the way I did there. It's the same thing. Are we all happy with the calculation? All right. Let's move. Next question says 6.3.2. The first repayment will be made 6 months after the loan has been taken or has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. I'm going to read the statement again bit by bit so that you guys understand fully what's going on. But I want to, before we read this statement, I want to draw attention to something really, really nice here or important. You guys remember when we derived the future value formula, the present value formula and whatnot, ne? We always assume that like a person takes out a loan here, ne? A loan here, and then makes either monthly payments or quarterly payments, whatever it is, ne? not immediately, but after that period. So if it's monthly payments, after 1 month, it's going to make his first installment, second month installment. If it's quarters, after the first quarter, it's going to make his first installment. So our calculation of present value or present value formula is based on the assumption that the person who takes out a loan pays a period later. So if it's monthly payments, it's gonna pay a month later. It's quarterly payments, gonna pay a quarter later. So that's how we derive this formula. That's the assumption under this formula, ne? So now let us look at this. Let's read this scenario here and try to understand it. So remember, um, okay, 5, 6, 7, and so on. Remember, the first repayment will be made 6 months after the loan has been granted. So he takes out a loan today, ne, of 212,500, ne, and then he's gonna make monthly installments, right? Instead of making the first installment here, his arrangement or the contract says he can wait until after 6 months. So that means his first payment is gonna be made here, the first X. Do you guys see that? And then the next payment will be made there. The next payment will be made there. The monthly payments there, but his first payment he makes it after 6 months. You guys see there what's going on there? Understand what's going on? Okay, so now I said just now, our present value formula is under the assumption that after taking out a loan today, you're gonna pay a month later if it's you pay monthly. If it's quarters, you're gonna pay a quarter later. But this one waits first. So that means we must we can't just like literally apply the formula as it is. You must think. So what's gonna happen is that you're gonna do this, ne? You're gonna take this 212 500, ne? You're going to It's going to gain interest within this period that you're not paying. This 212 500 is going to gain interest. So let's make it gain interest until there, ne? And whatever value we have there, ne? Whatever value we have there, the accumulated value we have there, then it will be our P in our calculation. So our formula will still be this, ne? But this P will not be 212 500. It will be whatever accumulated value at this time. So the reason why we stop at that time, because we know that it is basically the guy taking out the loan here and then a month later making the monthly installment. So we're trying to create this situation so that we can apply our formula. Does it make sense? All right, I'll repeat that. Yeah. So what I was saying was the present value formula is under the assumption that a person takes out a loan, if a person takes out a loan today, and then the arrangement on the loan is that he makes monthly installments, like monthly payments towards the paying back the loan. So this formula is based on that an assumption that you take out a loan today and then you start paying a month later. If it's you pay quarterly, you start paying a quarter later. So when we derived the present value formula, we 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 took that assumption into account. We assumed that is the case, that you pay a month later or quarter later, whatever it is, however often you pay. Okay. So now in our scenario here, this guy takes out a loan of 212 500, ne? But instead of him, and then he's gonna make monthly payments, right? They don't give us the monthly payments. They ask us to find the monthly payments. Now, instead of him making the first monthly payment a month after taking out the loan, they say that they give him a waiting period. Like they just give him a relief. You know, when you take out a loan, you're already financially stressed, so just give you a relief. Alright, man, let's give him 6 months, or for him to recover, So now, 6 months. So now you see, this is different to our assumption that you pay like a period after. So this guy waited 6 months until his first payment. So I'm saying that let us create that situation, that assumption. How are we going to create that? We take this amount, we make it gain interest for the 6 months, for 5 months, sorry, until here, so that we literally have our present value situation where someone takes out a loan today and then he pays a month later or period later. Do you guys see that? My sister? Tshego? Yes. Are you sure, Tshego? Wa kwishisha bolela. Re nyaka go voice ga go ra kwishisha. Elizabeth ya kwagala? Okay. Okay, sharp. So ke ntho e re nyaka go create down. That's what we're trying to create here. So Pharaoh, we do that. Now, this thing gains interest because I got at the bank. The bank says you go to the bank like, guys, I man, I want to make monthly installments, but ish, can you guys give me a relief for a few months, abo? Type of thing. The bank like, okay, it's fine, we'll give you that relief, but obviously the money will gain a bit of interest because we doing you a favor. That's what's going on. The arrangement, the logic behind it. Okay, so let's first of all, before we substitute whatever we substitute there, let's make it gain interest for the 5 months. Okay, on the side. So we're gonna go. Accumulated amount will be 212,500. Gained interest for like five months. What is the interest there? The interest is 13% per annum compounded monthly. We know that 13% is same as 0.13, and then monthly we divide that by 12. And how often or how many times did it gain interest? How many periods? For 5 months. Can you guys give me the answer there? Punch and tell me the answer quickly. 2 decimal places. Waiting. Yeah. Okay. Did you guys get the same answer? Okay. Pelo, can you check if you get the same answer? Remember that the number of periods we're looking at is 5, not 6. Pelo, please confirm if you are happy with the calculation. Proper stuff. So now this is the amount. This is the amount here. The amount there. So it's 224 262.53. So now this is essentially the loan amount he takes out at that time, effectively. Okay. So now the question asks us to find the monthly installment. They say the loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. Okay. So let's go ahead and substitute. Looking for x, ne? Let's quickly make x a subject immediately. With x is equal to p I all over 1 minus 1 plus I to the power minus n. Are we all happy with that? Okay, let's now substitute. We have x is equal to p is 2 4 262.53 ne? Times 0.13 over 12. I get the interest, okay, all over 1 minus 1 plus 0.0 0.13 over 12 to the power. Now this is the number of periods until the last payment. So now we are here ne, at month 5 ne. So now we want the number of periods until the last payment. This person pays this for 6 years. So let me just quickly throw a number line quickly, and a number line until 12 so that you guys see what's going on at the end of the year. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So now remember that the loan is effectively taken out there. The number of periods within a year is 1, 2, 3, 4, 5, 6, 7. I get 7. So it's basically 12 minus 5 is 7. Now, and then this whole thing happens for 6 years, right? So let's count the other 5 years. So how many months do we have in 5 years? We have 5 times 12 gives us how much? 60. Okay, so therefore the number of periods until the last payment is this number of periods plus the 60, which is 67. Punch that into your calculators and tell me the answer. Yeah, kwala bafowethu akere. Do you guys understand how we got that 67? Are we all happy? Remember that the end represents the number of periods until the last payment, not the number of years, whatever it is. Toko, are you happy? Mlauza? Ndebele, offense. Chokwe? Yes, ma'am. Yes, ma'am. Yes, ma'am. Yeah, I'll repeat. Okay, I'll do that. Okay, remember that the n under the present value um, represents the number of periods until the last payment. Again. So now remember that we are effectively there. The loan was basically taken out here. The loan of 224, whatever, ne? We're taken out there. So now we want to count the number of periods until the last payment. Remember that this loan is paid over a period of 6 years. But look at this. The loan will be repaid over a period of 6 years after it has been granted. The loan was officially granted here. Ne? Then they say that this guy will pay it for 6 years. I get. So now we say that the end represents the number of periods until the last payment. So this is the first year, right? And for the remainder of the first year, we count how many periods? For the remainder of the first year, we've got 1, 2, 3, 4, 5, 6, 7 until the end of the year. Get 7. So obviously, what's left is 5 years, and obviously, so 7. So what's left is 5 years, and in each of the 5 years, the number of periods is 12. We've got 12 months in each year, so it's going to be 5 times 12, which gives us 60 periods, plus the 7 gives us 67. So therefore, we replace the n with 67. My sister, are you happy? Proper stuff. Proper stuff, proper stuff. I'm glad that you guys are happy. Okay, so what I expect you guys to do now is just punch that and tell me the answer, because I don't have my calculator with me, even though I have it. But still, you get the point. Let's go. Waiting for your answer. Nah, 1000. Come on. Who's there? Is that Labla? Come on, guys, give me the answer there. Oh, get to me, eh? Are to me, bole? Yes, bole. Okay, okay. 2. Okay. Do me made a slight mistake. Do me look at your check. Look at this. See if you literally copied it as it is. Check that for me. Check. Do me. Okay, someone says 4724. Yes. Yes. Okay, do you get the same answer? Eh, o tile kae? Mo. Eh. Uh, okay, Gala, I'm happy to hear that. Okay, let's hear that. Okay, that's proper. Gala, what push out fanaka. So yeah, so that's the monthly installment that this guy's gonna make. I get. So yeah, remember this session is getting recorded. I'm gonna share it. Yeah, I'm gonna share it. Yeah, you guys are maybe like, oh, he's not gonna share it. I'm gonna share it. It's just that I explained at the beginning what happened. So I hope you guys forgive me. I hope you guys forgive me. Okay. Are you all happy? Must I move on? Proper stuff. Proper stuff. You guys are doing very well. You guys are attending, and you guys understand. I'm super proud of you. in a few years' time, in how many years? 4 years' time, you're going to be a breadwinner after getting your degree or certificate from college or whatever qualification or certificate, or if you become a pilot or whatever, you guys gonna be breadwinners. You're gonna be proud of yourself. So yeah, it all starts here. All of you are gonna be successful. Today, Andrew borrowed 200,000 from a bank. Okay, fair. Did we finish? Yeah, we did finish. So this guy Andrew borrowed 200,000 from a bank. The bank charges interest at 5.25% per annum compound quarterly. So here we've got the P. If you like, you can actually write everything from the beginning. Ne? As you read the statement, the question, you are free to sort of label whatever you get so that you give your mind something to work with. Your mind will be more reactive, responsive to the question. So this guy borrowed 200,000, which is P, present value. The bank charges interest at 5.25% per annum compound quarterly. That's your I, and that is 0.0525 over 4. Are we all happy with this value of 0.0525 divided by 4 as our interest I? Zona, are you happy? Okay. Then it says Andrew will make repayments of 6,000 at the end of every 3 months. Do you guys see? Okay, this is what is this? What is the 6,000? What is it in our present value formula? What does it represent? Our X. Okay, and then they say he'll make repayments of 6,000 at the end of every 3 months. So what is 3 months in a year? What is it? Is it half of a year? What is it? It's a quarter. So that means this guy's gonna make his repayments or installments quarterly after every 3 months. So this person who said the paper avoided using the word quarterly to confuse you. Ne? His first payment will be made in 3 months' time from now. So remember, this guy takes out a loan of 200,000 today. I forgot to tell you, every time you do a present value, like a financial maths question, please try to draw a number line. 10, 11, 12. So this is 1 year. I just put everything in months. So he takes out a loan today of 200,000. Okay. Then he makes his first installment after 3 months because he makes installments per quarter. The next one will be here. 3 months. 1, 2, 3. 3 months. The next one will be here. 1, 2, 3. Okay. 1, 2, 3. 3 months. Then the last one for the year will be there. 3 months. And so on. And so on. You can just continue like that depending on how long it is. But that's what it is there. That's essentially that. You guys get the idea of what's going on, eh? Now, this looks like an easy question, present value question, because it is consistent with our formula. Guys, remember that in our formula for present value, assume that once the loan is taken, this person will pay a period after the loan was taken out. So be it a monthly or quarterly, whatever it is. So this is a nice situation. It's very simple. So it says his first repayment will be made in 3 months' time from now. So from today and so on. How long in years will it take Andrew to settle the loan? So let's write down the present value formula. How long in years? Okay, present value formula. This you mustn't check on your formula sheet. You already know it. It's in your brain. You might even find that in the formula sheet, that person who said the paper made a mistake. So rather stick with the one you have inside your brain. So they're looking for the number of years, right? So let's substitute whatever we have, whatever we given. So we're given the present value. How much is the present value, class? How much is the present value? 200,000. Yes. Please, when you write it, you must leave a bit of space. And then what is our x? Where's Riboni? Is Riboni here? Oh, 6,000. Yeah, Riboni is not here. Ish. Okay, our I, we've already established it. That's 0.0525 over R4 to the power minus. I'm going to come to this shortly. Over 0.0525 over 4. Okay. Let's see. Okay, sharp. Yeah. So like we're here now. So they want you to calculate the number, the how long it took for the person to settle the loan. Okay. So now you guys remember that I said the n here at the top. This n represents the number of periods until the last payment. Again. So normally, if working per quarter, ne? If we turn on, let's just say we're given everything but not the present value. They're given everything, they're also given us this. They ask us to find the present value. You guys remember this thing is the number of periods until the last payment. So let's just say uh, this loan was repaid over 2 years, and then the installments are made per quarter. So we know that in a year we've got 4 quarters, because that's number, or 4 periods. 1, 2, 3, 4, and then the second year there's also 4 periods. So then, so it's gonna be 4 times 2. Basically that, ne? So now, where this is essentially the how often the payments are made. So if it was per month, it would be 12, but because it's per quarter, we've got 4 quarters in a year, we've got 2 years. So our n would be the number of periods until the last payment, which would be 8 again. So here we're gonna essentially do the same thing. We're gonna say, since in each year we've got 4 quarters, we're gonna put a 4 there, and next to the 4 we can put an m to represent the number of years. Do you guys see that? So all of this means the number of periods until the last payment, and this just means the number of years. So we're gonna solve for m. Does the explanation make sense? Radi, Lufuno, is jy reg my bro? Verstaan jy? Elizabeth ook sal gona ban. Wa kwishisha mara. O ratile wa kwishisha mara. Ndebele wa kwishisha mara. O ka Ndebele, o ka Ndebele o tlogile. Se se khona, okay, se se khona. Okay, fair. Sharp. So that's essentially that. So now let's solve for m. All right. So we will get rid of everything surrounding m so that we eventually remain with m. So now the first thing we do here is cross multiply. Why? Because you guys know this. I've said this more than, I think this year I've said it more than 500 times. A over b, a fraction equal to another fraction, you're allowed to cross multiply. So this is essentially a fraction. So you're gonna cross multiply this by this, this by that. Can you guys go 200 times 0.0525 over 4 and see if you get a nice convenient answer? Can you guys do that for me? Multiply the 200,000 with that I and tell me if you get a nice convenient answer. Proper stuff. 2,625. So it's convenient. So you don't just leave it as it is. You keep it like this. If otherwise, if you gotten like 2,625.567, you just leave it as it is. You just leave this as 200,000 times that, ne? So that you don't lose values. So on the right hand side, we've got 6,000. 1 minus 1 plus I to the sorry, I, but 0.0525 over 4 to the power minus 4m. Okay, sharp. Then you're gonna obviously divide both sides by 6,000 because you want to get rid of it. This will cancel that, and then on your calculator, you don't retype 2,600 whatever 25 again. You just go divide by 6,000. You don't stop. This will give you how much? What is 2,625 divided by 6,000? Quick, as a decimal, please. As a decimal. 0.4375 proper stuff, and then on the left remain with 1 minus. You don't even have to put the brackets because this number in front of the thing is gone, so just keep it like this. Okay, sharp, and then obviously you take the one to the other side. That's absolutely fine. Or if you like, you can take this whole thing to the other side. But let's just take one to the other side. It becomes a negative, so this will give us how much? 0.4375 minus 1 gives us how much? Please confirm. Okay. Then we could literally divide, could remove the minus by dividing both sides by minus 1. Okay, sharp. Are we together so far? So far, so good. Okay, sharp, sharp. So now, remember we did something like this yesterday. I told you already. Remember when you get like a question, an equation like this, and they ask you to solve for x, you try to make express this 8 in its exponential form, such that its base is such that it's got a base of 2. So like you're basically like re-expressing 8 in the form 2 to the power something, and this fortunately gives us 2 to the power 3. And then if the bases are the same like this, surely the exponents must be equal, so therefore the answer will be x equal 3. Yeah? But in some questions like this, you're not able to express 5 in the form of 2 to the power something. So in such situations, you use what we call logs. So you're solving for x, you're gonna go log 2 to the power x. What you do on one side, you also do on the other side. You go log 5. Okay. Now the reason why we take logs because there's an identity under logs that says log to the power log of a to the power n is equal to n log a. So it's, you just essentially take the exponent and put it in front and have n log a like that. So the reason why we do that is because we take logs in this equation is because we want this x to come down. So we're gonna apply this law and say this equals to x log 2 equal to log 5, and then after that you can divide both sides by log 2 to get x. I get it. So we're gonna apply this logs thing here because we have a similar situation here. If you look at it closely, we've got, let me put this on the left hand side. We've got 1 plus 0.0525 over 4 to the power minus 4m, 0.5625. Okay, so think of it as this as your as your 2 to the power x. Think of this as your x, and this thing is your 2, and then this is your 5. So you take logs. Okay, so you're going to take the log of the left hand side. So when you take log, you're going to have log. Why does it change color? Log 1 plus 0.0525 over 4 to the power minus 4m equals to what you do on one side, you must do on the other. Okay, then you will then apply that log identity that you're able to put the exponent in front. Okay, then after that, this is your home and dry now. It's clear cut now. So remember, you're looking for m, so you're just going to divide this side by, you want to get rid of that minus 4. Alongside that minus 4, you're going to get rid of log 1 plus 0.0525 over 4. What you do on one side, you must do on the other, so you must also divide this side by log 1 plus 0.0525 over 4. If you don't sleep early the night before the exam, I can guarantee it. At some point, you're gonna miswrite this thing. I can tell you for free. So therefore, m in years is equal to, let's do the calculation. This cancels that. This cancels that. Can you guys do me that calculation over there? Tell me the answer. You lost it, yeah? Go again. We lose each. Let's go again. Yes, you had it, man. The lady who was saying 11 point what had it, and I calculated just I don't know. Mashapa, ukraba kaya bafana. Sa presa ba khala. Re kweng Lerato Mokele, ukraba kaya man. Lerato Mokele. Tumelo Batuludi. Mza Roberto Baggio man. Roberto Baggio man ora lo kapa 94 man. Bosa chobelego man. Ena biksache ke bela kana ke. Apa like phenela ka final. Yeah? Au. Kwena mtsakone mfakola belo kotsa man. Chaban. Baggio. These guys that played today, ne? The guys that played today are too hyped, man. These guys that played today are not really good, man. We have too many average players now. There's a time where there was like superstars. Abo Roberto Baggio, Ronaldo, o Brazil, ona Zidane, ona Ronaldinho, ona le Rivaldo, ona le Pepe, ona le Romario, ona le bo Maradona. So that time there's just superstars everywhere. Now it's just good players but not superstars. Yes, can you see them loud? You got a question? Okay, you're getting an error. Okay. So what you're gonna do is to avoid the error, ne? Yes. Yes, my lady. Quick, you got 11.03 again? Yes. Okay. Yes. Why does Kanisila get an error? Because Kanisila might have left the bracket somewhere. Make sure that you copy this thing as it appears, ne? Like this. So it's log, you put the fraction thing, you put log, open bracket 0.5, whatever, close the bracket, over, -4, log, then 1 plus whatever, and then make sure the bracket is closed, then you're not going to get an error. Try it again. Try it again. Can you see them louder? Try it. Proper stuff. So the key was the bracket. Make sure whenever you get an error, do not panic. Check if you've put the brackets in the right place, or or you did not put a bracket. So that's ultra important. Yeah. We're good now. We're good now. Let me save this second part of the session so that it doesn't freeze or whatever dump us. So it's good.